Students, this question was asked in NEET exam 2019 from chapter 5 of class 11, that is from the chapter of work, energy and power. A particle of mass 5 m at rest suddenly breaks on its own into three fragments. Two fragments of mass m each move along mutually perpendicular direction with speed v each. The energy released in the process is how much? Students, let us draw the situation. Two fragments move perpendicular to each other with the same speed v. Okay, students, suppose this is v and this is v. So there are three fragments, and according to principle of conservation of linear momentum, the momentum of the third fragment must be equal in magnitude and opposite in direction to the resultant of these two linear momenta of these two particles of these two fragments, so that the final the total linear momentum of all the three fragments will be equal to 0 after the explosion, because it was initially at rest. So the initial speed of the body, entire body, was 0, and the initial angular moment initial linear momentum mv of the body was 0, student. So the sum of the linear momenta after the explosion or after breaking also should be 0. So student, if this is v and if this is v, both are same in magnitude and are perpendicular in direction, we know then their resultant will be equal to how much? Root 2 v, because this will be v square plus v square root, this will be root 2 v, student. So this is the resultant of the velocity. Okay, student, and obviously this will be the resultant of the linear momentum of the two fragments. So students, what will be the direction of the third fragment? This will be equal in magnitude but opposite in direction to this one, so that this plus this will be equal to 0, students. So the question asks the energy released in the process. Energy released in the process will be how much, student? E will be equal to E1 plus E2 plus E3, the sum of the energy of all the three fragments. Okay, student. So we know this will be equal to half m v square, because one mass has mass m and velocity v, and the second mass is also having mass m and velocity v, plus third mass is having how much mass? It is the total mass is 5m. So the third fragment is having mass 5m minus m, that means, student, 3m. Okay, 3m. And what is the velocity? That is, suppose that let us take it capital V. Okay, student. So this will be capital V square, and we have to find out this value of the capital V, so that we can find out the total energy. And how can we find out this capital V, student? That can be learned from the conservation of linear momentum. So students, the initial linear momentum of all the three fragments was 0. So the after breaking also the linear momentum of the three fragments will be equal to 0. That means, student, this root 2 v into m. Okay, student, this is the resultant of the velocity of the both the particles into mass of each of them. Okay, student, will be equal to how much? Will be equal to the momentum of this third particle, and the third particle has mass how much, student? That is 3m, and it has velocity v. So from this relationship we can find out what is the velocity of the third fragment. That will be equal to this m cancel, student. M is in both the sides, so this will be equal to root 2 by 3 v. Okay, student, this will be root 2 by 3 v. If we put the value of v from this equation, then we can get the total energy. Let us put it here. In place of v, we write root 2 by 3v. Okay, student. Square of root 2 by 3v. So this will be equal to half mv square plus half mv square, half mv square plus half mv square plus this third term is half into 3m into this is 2 by 3 into 3 and this is v square. So these three, this one 3 cancels out, these two and these two cancels out. This becomes student 1 by 3 mv square and this is half mv square and half mv square. So student, we may write this as mv square plus 1 by 3 mv square, that is 4 by 3 mv square, that is in option D. So students, option D will be correct for this question.